And there'll just be one example down here. Suppose alpha is an angle. This will go on the bottom. In quadrant 2, and beta is an angle in quadrant 3. Such that sine of alpha is equal to 4/5, and this is a lot of text. Cosine of beta equals -3/4. Alright, after you finish writing it, look at those values I gave you, those ratios. Is 4/5 or -3/4 on the unit circle?
No.
No. If they're not on the unit circle, what do we have to do to solve? And all?
You can use it like put a triangle and put in quadrant 2 for alpha and then quadrant 3 for the beta.
We're going to need to draw some triangles. So let's go ahead and sketch your x and y axis. And we're in quadrant 2 and 3. And that's how our triangles are going to look. I'll talk about why the side is shared later. Sarah yesterday brought up a really good question. How do you know these are the same length here? Because they're going to be a shared side. Sometimes they're not, but in the scenarios we're going to be dealing with, they should always be the same here, given the information. So we know that this triangle is alpha in quadrant 2, and in quadrant 3 we have our beta triangle, or is an angle there. Now we're back to chapter 4. In chapter 4 I just gave you one of these, and I said, alright, here's a fact. Go ahead, fill in the fact, and then find the missing sides. Now we have two triangles. You need to use that information to complete them. But before we do that, I want you to label opposite, hypotenuse, and adjacent. Label each side. Daniel Liu, what is my opposite side in alpha?
4.
4. And my hypotenuse?
5.
Perfect. Let's see. Stephanie, what is my hypotenuse in beta?
4.
Okay. And then my adjacent?
-3.
Good. And it's shared between each one. How do we figure out our missing side? Pythagorean theorem. What did you guys end up getting? Rad 7. I want you to leave it as rad 7. Because I think you get 9 plus b squared equals 16, right? And you get b squared equals 7. Rad 7. Let's write it in. Now this is not completely right. What's wrong with it? I like the radical, actually. It's a negative. Why is it a negative?
Because it's going down.
You're going down. Make sure that negative's on there. That's why it's drawn in quadrant 3.
Clarification question.
We don't like buttons. All right, here it is. So, knowing that, we're going to jump straight to it. Find the exact value of sine alpha minus beta. Manal, question.
Right? Cosine B.
Who's got the general formula for me? No numbers, just general formula.
It's sine and then alpha, positive or negative beta, plus or minus beta equals sine alpha cosine beta plus or minus cosine alpha.
All right, so for this case, if I'm dealing with negative, what am I going to deal with when I'm expanding? Subtracting. We can think of this as sine, you use the same sign. Cosine, you use the opposite. So same sign here, negative, negative. What comes next? Cosine alpha, sine of beta. Now, I want to simplify your life a little bit. This is great. Sine of alpha, do we know that information? What is it? You do not need to rewrite sine of 4 over 5 because you know that sine of alpha is 4 over 5. So you already have the ratio. It's just 4 over 5. The trig ratio disappears. Cosine of beta, what do we have for that? Negative 3 over 4. Do you have cosine alpha and sine beta?
We can.
You can find it, right? You have triangles. Absadi. I think you did.
I looked back at it.
I was just thinking about it when I was writing this down.
I forgot the rad 7 is negative.
Yep. Guys, be careful with your signs. I put up A. Deal with this first. It's plus, right? Negative times a negative is a positive, but you're subtracting it. So it becomes a negative. Yeah, you gotta check your sign here.
I just did it because if it's negative here and we're subtracting, wouldn't it become positive?
Yes,
So
you're
it
right.
would be 9 plus 4 rad 7.
You're right. All right. Here are the two answers. The hardest part of this, guys, is just getting the signs, probably. Any questions on the signs or the numbers? I mean, now's the time to ask.